Cool. So we're going to talk a little bit about manual testing and some confusions that we have in the testing community. It also appears to me that we testers are good at many things, and one of these things we're really good at complaining. So I thought it would be good to complain a bit about things in the testing community. So first of all, who am I? My name is Ilari Henrik Aegerter. I use the internet translation service. I hope that is correct in Cyrillic. I'm not sure because I can't read it. So I'm the managing director of a company called House of Test. We provide testing services in Switzerland. I'm also the VP of marketing of the Association for Software Testing, which is a non-profit organization that tries to make testing better in the world. And last but not least, I'm also a beer brewer. So I do something with my hands because in my usual job, I just fill in forms and do nothing productive, actually. Okay, one disclaimer here. Always keep in mind, I'm a damn consultant. And even worse, I'm also a manager. So you have to be very suspicious of what I'm saying. I would also say that generally that's your task as a tester, to apply a healthy dose of skepticism to everything you encounter. Just because someone stands here in front of the podium and has a nice suit on, a jacket, that doesn't mean that I have bought into the truth of the world. That also means that during the presentation here, if you disagree with me violently, then just kind of, ask me a question or interject. That's perfectly fine. So you can say whatever you want. Cool. So what is exactly my problem? What's particularly my problem here? What I think is that in testing we have a lack on the distortion of a systemic conceptual model. There are different flavors in testing where there is a focus on one thing, whereas the focus should be on something else, or they over-rely on specific actions or activities in testing, and that leads to a craft that is less than ideal. That also leads to that there aren't that many good testers around. In my lifetime, I've probably conducted several hundred in-person interviews with testers. It's in my previous job, I used to run the testing business for Europe for eBay, a company that sells goods on the market. And I've always encountered that most of the testers that I interview are not really qualified to do their job. And that can have several reasons, especially the mix of different categories are in the wrong direction. Cool. I have found out that often it is good to willfully decide what not to do. So there are a couple of things that it's better not to do. So we probably all run our to-do lists, right? Do you have to-do lists? Yeah. So how about running a not to-do list? A list where you list things, okay, these are, that's stuff that I don't do. Okay, so first of all, let me ask who is here. So who would regard him or herself a tester? Okay. Who self-declares as a developer? Okay. Who is a damn manager? Ah, there are some managers here. Very good. That will be fun. Who is a consultant? Okay, that's interesting. That's very good. So we have a mix here. That is great. So let's have a look. There is the predominance of certifications. You see that all over the place, that people are certified in testing. What usually means is that you go to a 3-day course and then you fill in the multiple choice questionnaire, and after that you're a certified tester and you're skilled and you're allowed to shoot in all directions you want. Now just imagine the same thing for developers. So you developers, you don't go to university for 3 or 5 years, but instead you get a book that you memorize. So it asks questions like, what is a class? And then you have answers like, okay, it's a noisy group of young children, it's and then you cross the right answer. And then you're allowed to develop whatever you want. Or imagine the same thing for doctors or for airline pilots. So what is a wing? And then you are supposed to fly a Airbus 380. Isn't that great? So that would be very fine. So the claim that these certifications give you any sort of skill is preposterous. So this is also good. The organizers have organized vodka for the speakers. That's fantastic. So let's see. So I'll give you an example, a story out of my own experience. I had a guy at eBay. He used to work with eBay stuff. That means he handled the biggest Oracle database instance on the planet, had very complex work environment where he performed really well, and then he decided to leave eBay. He used to work in Switzerland, where I'm from, and he went to a big telecom company, and they asked him during the interview whether or not he's certified. His interview was interrupted on the spot because they said that's a must requirement, you can't have the job. So they just exchanged the presence of a piece of paper with real skill. I think this is an effect that has been shown a lot by HR departments who have no means to decide who is a skill tester or not. It goes into the same category that the whole testing craft is commoditized, which means that, okay, let's get just cheap, unqualified people and let them do the testing job. That also leads to a standard. So there is actually a testing standard, it's called 29119. Now, I think the main reason why this is not a good idea is because you can partition systems into two different categories. Systems that gain from variation and systems that are harmed by variation. So let's say here in Russia, all the electricity plugs were just in some fashion. Just imagine what mess that would create. So you would have to have thousands of adapters, or another example would be battery sizes. So if you had 1 million different battery sizes, that would be really painful because you could never find a battery for your slide changer or for any gadget that you're using. Just imagine what mess that would create. Very unlike software testing. So software testing is a system that absolutely gains from variation. The more variation you bring into testing, the more likely you are to find something interesting in your product, right? So if you have a system that gains from variation, standardization is not a very good idea. I've started to see projects where this is a must that you comply to that. So the 29109 standard is a several hundred-page thick document of garbled, incoherent mess. So I would completely refrain from ever advocating such a thing. So this has also led that instead of testing, we suddenly focus on secondary work products. So how is this a good situation when you're focusing on creating a several hundred-page thick test plan, and then you have a kind of a strategic test plan and all the stuff that is mentioned in these over-bloated procedures? How does this help anything in finding a good bug in a product? It doesn't, absolutely not. So you're focused suddenly on creating a paper trail instead of doing real work. So in testing, you could actually partition the system in kind of setup, testing, and investigation. So setup is when you set up your testing environment, any work that helps you to prepare for testing. You should absolutely reduce that time as much as possible in order to spend most of your time in testing. So your workday usually has 8 or 9 hours. If you decide to spend 7 of these hours on creating documents, you have not gathered any sort of information about the product that helps you to make it any better. So try to reduce that. You should spend a lot of time on testing. If you start to focus on the shiny documents that please managers, that's not very nice. And I know what I'm speaking of. I've been a manager for a very, very long time. So we are suckers for these nice graphs, and especially if we have percentages. So it's kind of 90%, that's cool. It's kind of 91 is better. 91.3 is even better. 91.37, that gives us this warm and fuzzy feeling in the stomach of precision and science and everything like that. So not such a good idea. Who is a technical tester in here? Who does predominantly automation? Okay, very many. So one important thing to keep in mind, I find automation an absolutely essential tool in testing. So if you have a setup of a complex system and you don't have any automation in place, you're in deep trouble. You should be absolutely worried that something goes wrong. Now there is another extreme, which is the automate everything sphere, which means that, okay, so everything that is being tested should actually be automated. That is not possible. You can't do that. It's not possible to do that. Sometimes it's not advisable because the costs are too high, and sometimes you can do it. And I'm going to make a short demonstration of why that actually doesn't work. So we have this piece of high equipment. Tech, okay. So just imagine I'm a company, we have a product, we're very proud of that product. It's called Calculator. It's revolutionary, it allows you to add numbers and then spit out the result. So you got this here. And also we're very modern in our development process, so we work with minimum viable products. So we actually want to go out to the market and test it as early as possible. And so let's do that. So first of all, we have implemented the function 2 plus 2. So now we want to go out to the market and see what happens. Now, question to you all guys. So you have this little calculator in your hand, it fits in your palm. And then you press 2, then plus, and then 2, and then the equal sign. What do you see on the display? 4? 4? So you see a 4 on the display? 4? Well, 2 plus 2, and then the equal sign. And then you see 4. Do we agree all in the room? We see a 4, huh? That's an easy thing. Okay, completely wrong. You now acted like computers and not like humans. Huh? Why? Because the calculator is obviously not switched on. And so as a human, you can actually see that. And of course you know that if you press 2 plus 2 and then equal sign, there's nothing happening on the screen. But now you just acted like computers, not like humans. So as humans, you're very strong sense-making machines. You're really good at sense-making. So you have a quick glimpse on it. It's not switched on, so of course you switch it on. Okay, small trick, but let's switch it on. Usually a calculator displays this kind of 0 here, right? Huh? Okay, now we want to automate all the test cases in this little application, which is just a 2 plus 2 calculator. Now the precondition is it is fed with infinite energy, so battery lifetime is of no issue, so that works all perfectly well. Also, the only sequence that needs to work is 2 plus 2 equal, and then you can press the cancel button, and then you can start again 2 plus 2 equal. That's the only thing. You don't have to calculate 22 plus 2. You don't have to kind of press 2 and then twice plus. If the world explodes, that's just fine. That's okay. We can just signal that out. So let's automate that. What would be your first test case? Okay, I'll give you one. So so the first test case would be I press 2. I expect a 2 on the display. Then I press the plus button. My expectation would be kind of the 2 flickers slightly, but there is still a 2 on the display, right? And then another 2, it's still 2 on the display. And as soon as I press the equal sign, I expect that there is a 4 on the display, right? Okay? And then I press the C button, and my expectation would be it goes back to 0. Okay. Any other test cases you would implement? No, out of scope. If the world explodes, if you do that, that's just fine. Okay. Repeat. Okay, how many times? 3 times. Why? Okay, and 3 is enough? Anyone wants more? I mean, this is automation, it's cheap. Yeah? Yeah? Well, I'm a computer, I can't handle a week or a month. Give me a month. Let's say 1 million times, right? Are we okay? 1 million times? Repeat 1 million times. 1 billion? Okay. That's easy. It's just an addition of 3 zeros, that's okay? Okay, 1 billion times. Any other test case? You need to be sure that there is no bug in the product. Yes? That's out of scope. If the world explodes with that, no problem. Yeah. No. The sequence is always 2 plus 2 equal and then C. Then it starts again from the beginning. Everything else is out of scope. If there is any problem in that, who cares? Timing, good? Yes? Okay, fast or slow, can't compute. Give me specifics. I'm automation. Yeah. Mm. Okay, I'll give a suggestion for a third test case. We randomize the speed of input, and we have a variation between 1 millisecond and 1 week. And then we run it for a year. Okay, good, good. 1 millisecond to a week, run 1 year. Yeah, it's a bit shorthand there, but okay. Okay, any other test cases that we need to, yes? Out of scope. You don't have to, it's just there. The batteries are fed. You don't have to care about your batteries. Okay. Okay, how much?
Ilari, sorry, could you please repeat the command from?
Yes, sure.
Because
okay.
we have online
absolutely.
people.
So he said it's kind of the pressure on the button should be a variation. Okay, so give me a range. Okay, anyway, let's have a range of button pressure. Okay. Are we now sure that there is no bug in the product? Out of scope. Yes? It's going to be used to calculate 2 plus 2 and see if... Good question. So this is kind of the usability question. So where it's being used? Is it being used on the moon or underwater or something? No, office environment. Yeah, we know exactly, because it's only licensed for office environments. Yeah. We already have that, number 3. Yeah. The pressure time. Okay, let's have 3A time, so we add that as well. Okay, cool. All right, but now we're sure that it works. There is no error in that. Yes. So power is fine. We have no. Oh, we have that here. The kind of the number 4 is kind of the pressure weight in Newton. So the strength you press, you mean? Yeah, that's in number 4. So this is kind of how much pressure do you apply? Yeah. Okay, but now we can be sure, right? No bugs there. Okay, so localization as in Arabic numerals. This is specifically made for the American market. US market, yeah. I just made it up, but yeah. But this is a good point, of course. Is there any internationalization needed? Maybe not. Okay, but now we can be sure there is no bug here. Usability as in? The color. So, okay, let's have some international cultural elements. So basically it is kind of this grayish background, and the numerals are in black, which should be fine, I hope. Accessibility. So does it have that? Yeah. So, okay, I just make number 5, I make the ilities. Okay, so we just covered that. It's kind of, we round up all the ilities here, yeah? Drop test. So it's kind of whether or not it's, okay, stability. Yeah, okay, let's add that as well, cool. But now, let's see, is there anything else? Okay, I press 2 plus 2, then the equal sign, and I get a 4 here, and there is an additional 5 here as a decoration on the left side. Would you report that as a bug? Would you report that as a bug? So I press 2 plus 2 equal, there is a 4 here, and I have a 5 on the left. Would you report that as a bug? Yeah, you see, you would report that. Okay, let's add that. Why didn't you find that? Now you had no trouble in identifying that this is a bug, right? Okay, I press 2 + 2 = sign, and the calculator gets incredibly hot, and you burn your hand and let drop your calculator. Would you report that as a bug? Of course you would. Okay, I press 2 + 2 = sign, and the sign comes up, and there is a unicorn on the left side. Would you report that as a bug? Yes, of course you would. Now, you had no trouble in identifying that these are bugs. Now, just to explain to you what is happening here is you have detected the violation of your implicit expectations. What is very, very hard in testing is come up with all the ideas. What is really easy for humans is to detect when something goes wrong. And this has probably some evolutionary effect, because if we were standing in the savannah and there was some rustling on the right side, we didn't analyze what was happening, but we immediately decided, okay, that might be a saber-toothed tiger attacking us, and we ran away. We are really good at doing that. So the same thing is here. If you had to come up with a list with everything that goes wrong in this room, and you brainstormed for 10 hours as a full group, I am sure that the following example would not have come to your mind. The Russian National Circus airplane has just taken off from Domodedovo, and the cargo door opens and smashes away, and one of the circus elephants is ripped out of the airplane and crashes into this room. You would certainly put that event into the bucket of things that can go wrong in this room, but you wouldn't have come up with that example even if you had a brainstorm for a very long time. And so the reason for that is that we are really good at detecting things that go wrong, but we can't come up with a scenario of that. Now, everything that falls into that category by definition is not automatable. So when there are events that you can't foresee, these are your unknown unknowns. If you have these, you can't automate that because they are not, it's not possible to put them into. Okay, so in terms of automation, you can automate everything that is foreseeable, something that you know, because you need to tell the computer what it is supposed to do. If you can't do that, you can't automate it. So a very, very important point to keep in mind. So what is software testing? So if you had to explain to someone what software testing is, of course it has a lot to do with programming. Often we program, especially on the automation side. But what's the essence of software testing? What is it? It's kind of the revealing of quality related information. So what business we're in as testers, we're in the information delivery business. That's what we do most predominantly. We deliver information that is valuable for stakeholders to make educated decisions, right? So it is not only just the implementation of automation. What I've seen in automation also is that the part of test design is not being considered adequately. So often there's not that much thought put into that. And what happens there is that we often try to find what is provable. So the application should do A, so we check for A, but not that much for anything else. There are a couple of people, James Bach and Michael Bolton, and they have set up a kind of a distinction system between what they actually said, not this, they said checking versus testing, but I find that's a wrong description, because for me testing is every activity that will reveal any information. Now checking is the confirmation of existing information. So you know that the application is supposed to do A, then you go into the application and see whether or not the application does A, and if it does so, then it's fine, and if it doesn't, something goes wrong. Now, also in terms of automation, we not only have passed and failed of test results, so each of these has actually at least 2 more branches. If you have a passed test, that doesn't mean everything is fine and you can release. And the same is valid for if you have a failed test. A failed test does not mean that you definitely have a problem. Say you come in the morning and you have a regression suite with, say, 100,000 tests. Some of them are always a bit flaky, and then suddenly everything is green. What would be your first impression? Certainly not, oh, a wonder has happened and we suddenly don't have any problems in the product. But you would think something is fishy here, let's have a look. And then you see, okay, it didn't go wrong. Now the same thing, you come in the morning, everything is red. All 100,000 tests are failed. Your first expectation or kind of your first assumption is not that now the developers have really messed up, but your assumption is that probably the test environment wasn't ready or something went wrong. Again, you're the sense-making machines that need to be applied to the whole problem. You don't kind of binary make a decision, okay, now everything is wrong. So you have the effect with past test cases that you will miss a bug, and then you also have the false alarms with failed bugs, failed tests. On the other hand, the experimentation side, this is the part that will reveal things you didn't even know you didn't know. So the unknown unknowns are only revealed through experimentation. And by very definition, you can't automate that. You can't automate the discovery of new information. That is very, very difficult. Now, what I just said, you should completely disagree, because that's not true. Very often, you can apply automation to yield a lot of data that you then interpret, and you might discover something new. So even with automation, you can make experiments. But in here, I find it advisable to make a good distinction. And also, this is not, I'm not throwing kind of, okay, you need to relabel your unit tests as unit checks. I think that's silly. So there are a couple of people in the testing community who think that, well, unit tests should not be called unit tests because basically they're not tests, they're checks. I find this very pedantic, so I don't think you should do that. So if you call them tests, that's fine. But in your head, make a conceptual distinction between whether or not you're verifying explicit knowledge that you already have, or if you're experimenting to reveal new information. I find that a very good partition of your activities, that you're aware, okay, now I'm experimenting and see whether or not I find new information. So here we go. TDD is in that sense not testing, although you call it testing, and I'm fine with that. But in that, it's not the sort of testing that reveals new information. If you want to do that, then you need to apply Ashby's law of requisite variety, which means that if you want to see systemic failures of your product, unit tests won't help in revealing them, because your steering system needs to have a higher level of complexity than the system that you're actually testing. Very important. Now to my title, kind of there's no such thing as manual testing. And this is interesting because in the afternoon there will be Jan-Jaap Kannegieter, who will speak about manual testing and the value. And we had very interesting, where is Jan-Jaap? There. And we had very fruitful and interesting discussions on that. We kind of disagree, but still agree in many areas, which is pretty cool. Which also to you is an advice. If you disagree with someone, that's where it becomes interesting. That's where discussions can happen. And just because someone has a different opinion doesn't mean that this person is a bad person. I find that very important. Yeah. So that means now it becomes interesting because you will have to defend your own opinion and you can have an interesting discussion. So I've had many good discussions with people that completely disagree with me. And I find that always very rewarding. That's a good thing. So what is my argument here? Okay, question here. Can I see a developer? Who's the developer here? Okay, here we have a developer. All right, so Mr. Developer, that's interesting. So you obviously develop software. Now, are you a manual developer or are you an automated developer? So I observed you work, I just made it up. I observed you working. I can see your hands on the keyboard. So you're working with your hands. So quite obviously you're a manual developer, right? Huh? There is such a thing as automated development. You just call it differently. It's called compiling. That's what automated development is, right? So as you can see, people were chuckling here about the distinction for manual and automated developer. It doesn't make sense at all. Now, I believe that it doesn't make sense in the sphere of testing neither, because in the same way as with you, your hands are a specific tool that allow you to enter something into the system. But that's not the guiding principle in your activity. It's usually your work. It's kind of your brain is the important part. Your brain is involved. And that is the important thing. The manual aspect of your work is not in the same way manual as if someone takes a shovel and shovels sand from one area to the other. Now, the reason why I object with this distinction between manual and automated tester is that as soon as you apply the label manual tester to someone, that already insinuates that this person is less skilled and that actually that work is just an intermediate phase into having things automated, because now we're still doing it manual because we're not ready yet to automate things. And then you have this manual tester who is just someone you just grabbed from the street, a homeless person, and sat in front of the computer. I'm exaggerating a bit. But at least in Switzerland, where I'm from, if you have the label manual tester oh, poor person, it's kind of, you haven't made it, so that's really unfortunate. It has this label there. So I don't find this very useful. What I find useful is that as a tester, you all go and see a product and then you identify the sort of problem you want to solve, and sometimes automation is the solution for that. And sometimes conducting experiment is a solution for that. Sometimes the solution is just to ask questions. So what I find as a tester, you bring a lot of value at the beginning of a project to ask the critical question. So, okay, have you thought about testability here? So how does the architecture look like? Is it, will you be able to implement automation later on? Are there some good test APIs available? How about logging, things like that? Or, okay, so if you construct this, I don't think our market will appreciate that, because I know from the previous project, they went bust because they implemented something in that way. So I think as a tester, one of your tasks is to ask the critical questions, and it's not very helpful to do that. So what I try to distinguish is kind of, okay, to what degree do you take tools into use for your testing? You always take tools into use for your testing, even if you just interact via your keyboard, because there is a keyboard driver and there is a mouse driver. So there is never a thing where you don't take any sort of tool into use for your testing. Also, this distinction, manual versus automated, it's kind of contrarian. It's not so helpful. Very often, you don't have just full automation. You just write a quick script that will help speed up your testing. So I think the level of tool usage is on a degree. It's not something that is just switched on in a binary fashion. Okay. So, very important, software testing is not complicated. Do you agree? Do you agree with that? No, of course not. We're skilled people. Of course it's complicated. If it was easy, everyone could do it. Now what I mean with this is something else. And I take the Kinefin model of making sense of different systems that you find yourself in. So you can... can't be true. You can't see anything? Yeah, you can see anything? Okay, good. So Dave Snowden, who has developed a model for sense making, okay, to see, okay, what sort of system are we in order to see where we work. He divided into the right side, which are ordered systems, and then on the left side, these are complex systems. The way he distinguishes between these is that in ordered systems, if you apply a method algorithmically, you will have the same outcome every single time. Let me give you an example of a simple system. 2 + 2 is a simple system. Basically, you apply best practices to do that. So you just add these two numbers and it will yield 4. Now, a slightly more complicated ordered system is one that has, let's say, a long mathematical formula is a complicated system because it needs analysis and you need to solve it in a specific way. But again, you will solve it algorithmically and that will yield the same result each single time if you do it right. Whereas in complex systems, you don't really know what's happening. Now, software is not a engineering-only system. It's a human technological system. Software is used by humans, and we humans are inherently messy, and we are not predictable. So the prediction of how I react if someone says good morning to me is not always the same. Maybe I have a bad mood in the morning, and then I just grumble something, or I'm very upbeat, and then I say, hey, good morning. So it will have a different outcome. Now, the way to act in complex system is to do a lot of experiments and see which ones yield to interesting results, because you can see what's happening. Just to give you an example of a complex system. A roundabout, cars. So there are usually kind of 4 entry and exit points, and there are cars. Now, the more cars you inject into the system, the more different it will act, but it's not foreseeable in what way it will act. The same applies to a traffic jam on the highway. So sometimes there is just a threshold where there's too many cars, and then some human element does a little break, for instance, and then everything comes to a standstill, and there is a 10-kilometer-long traffic jam. But it's not foreseeable what's happening there. So complex systems are inherently difficult or impossible to foresee. I find that very applicable to software testing, to think in that. Also, it explains that many organization try to tackle the problem of software testing in a way it is done in a complicated system. Try to write down a lot, also try to analyze to the last little bits that is possible, make a very detailed project plan that is split into into minute increments of what people are doing. And if that doesn't work, sometimes the reaction of people is, okay, let's do the same thing a little bit more. Let's document a little bit more than we just did before, or let's add an additional document to that. So you see the difference there? So very often people act in software testing as if it was a complicated problem instead of a complex problem. Not very helpful. Cool. So if you hire testers, usually what I'm looking for are some obvious things. So, well, have you tested before? So I think that's an interesting question to ask. That usually shows also in the CV. I'm also very much interested in okay, how deep is their engineering knowledge? So how deep are they into software development? I find that skilled testers should have a couple of elements of software development as well, and should know what's happening there. If a tester is completely untechnical, I don't think that person can do a very good job. Now, I know that some people disagree with me on that, but I believe that this is true. The ability to think in abstract terms. So if you come up with some test design, what you're actually doing is you build a model of the software that you're testing. You need to make an abstraction of the software, and then you compare your activity against the model that you have built. This requires a lot of ability to think in abstract terms. Then here, so that's kind of my lower limit for someone who is not a software developer. A tester who has not studied software engineering or can't develop software him or herself should at least be able to have a meaningful interaction with a person. There's a guy called Harry Collins, and he has come up with the term interactive expertise. That means that you can have a meaningful discussion with an expert without being an expert yourself. That's a knowledge level that can be helpful to do that. When I do interviews, I give a task that requires to take note. I'm astonished by how many testers do not have a personal notebook they always carry with them. So do you always have your notebook that you take notes? I don't think that if you're tackling a very complex problem in a software, that this is tackleable without taking notes. So this kind of being a concise writer of text and also taking notes for your testing purposes and delivering a report to someone who reads it in a way that helps that person to make an educated decision. I find that a very important capability. Good. There should be champions in curiosity. Who are the natural champions in curiosity? Children, yes. So who of you has a, say, 4 to 6-year-old kid? All right. Have you ever tried to walk from A to B very fast and been very frustrated at how slow it actually goes because they see all sorts of things and they suddenly become interested in their own shoes or anything that surrounds them? I think these kids, they are not bound by any business pressure and goals set by managers, so they usually are kind of free to be super curious. So I think the biggest masters in curiosity are actually our kids. Then, of course, precision and accuracy is super important to have that. So this is a no-brainer. Yet still, I think a healthy sense of humor is super helpful because as a tester, what you often do, you tell a developer that his or her baby is ugly. Now, that's a message that's very difficult to convey. It's not something that is easy. It's not, okay, it's ugly. It's a difficult message to do. And I find humor is a good method to circumvent social pressures. Good. I want to talk a little bit about community. So this here is a conference. So we have Heisenbug conference. There's a lot of people here. Now the value, the highest value, I believe, you will take from this conference is by exchanging your ideas with anyone else here. So during the breaks, in the evening tonight, during lunch break, just find someone that you haven't spoken to, just ask them what they're doing. It's amazing how much you can learn by building a community. That also means that you could enter a professional organization. So, of course, so this is without any own interest. the Association for Software Testing, a beautiful non-profit organization that also offers courses in software testing. So I can advise to become a member of that organization. But of course, I'm from the board of that, so I might not be super neutral in that. Good. Twitter is also a very good means sometimes. Now, Twitter is horrible because people get into fights and then they start to insult each other in a way that's not very helpful. Now, that results from it being constructed to 140 characters. It's very difficult to have a meaningful discussion there. But sometimes to ask for advice, does anyone know XXX or something like that? And then you will get a link to a good way of testing. Then, of course, go to conferences. So Heisenbug, a very good conference. I can personally recommend CAST, which is in the US. It is a conference that has a lot of the conferring element where people exchange ideas, which means that usually the sessions are 40 minutes and then there is a 20-minute slot of discussion, of active discussion within the audience and the speakers. There's another one, Let's Test, I can recommend. It is tucked away in Sweden, outside of the city, in nowhere. And usually people stay together and confer all night. That's very good. Copenhagen context. There are many more. If you're interested in more conferences, just talk to me. I have a couple of that I can recommend very warmly. Also read testing blogs. So many people read testing blogs and they also write. So the second keynote speaker Rex has a blog. I know Jan Jaap has a blog. I'm sure that many in here have blogs that are useful, where you guys reflect on testing and what's actually useful. So you can learn a lot from that. Then in terms of education, who has studied software testing at the university level? No one? You? You have? Oh, tell me more. You have studied software testing. You have a degree in software testing. Yeah. Testing modules. Okay. Right. Yeah. So yeah, that's what exists. But there is no degree. There's no master's degree in software testing, which is weird. That should be something that should be available on the market. But unfortunately, it isn't. So what can you do in education? It's very difficult to find something. So these I find very useful for reflections on software testing in general. These are called BBSD classes. They were developed by Cam Kainer, who is a professor at the Florida Institute of Technology. He's a software engineering professor, and he has come up with this online course that takes 4 weeks. It is very tough because you will have to spend about 15 to 25 hours a week in addition to your workload in going through that course. It's a very interactive element because you will have about 20 people that are distributed on the planet, and you will be interacting on an online platform and solve some tasks. So there is reading elements and then there are exercises. That's a very deep way of going into testing. So BBSD classes are something that I recommend. Now, if you fancy doing something shorter, there is rapid software testing, which is from James Bach and Michael Bolton, and there are a couple of other people that offer these courses. So they are 3-day immersions into critical thinking, basically. It's less about the application of testing, but it's very much into how you think critically about things. Cool. So here we go. What do I think is important on a high level? And as I mentioned at the beginning, I'm a manager and a consultant, so I'm by definition high level. I think constant learning and acquiring a deep understanding of what testing is. And by deep understanding, I don't only mean understanding how you apply specific tools, but okay, how do we think in a way about software that allows us to find the most interesting bugs? Then via negativa, which is the path of deciding things that you deliberately do not do, might be a good way of getting better at testing. Number 3 is most important to me, since testing and software is not only a technological system, but humans are involved. You need to be proficient in psychology and philosophy, in the human arts. These are very important. So kind of usability testing is not based on engineering knowledge. If you combine these two, then you will become a very skillful tester. And of course, the community, the more you build your own network of people, of like-minded people, where you interact very intensively, the more you will be able to make your skills better. And then, of course, there are more. That's not a complete list, as I do not claim to have the truth in my hand, but just that. So I would like to open the floor a little bit for your questions. I think we have 5 minutes left. Yes, over there. I will repeat the question. What sort of beers? Well, mostly West Coast US American IPAs. That's what I like most. I'm in a very deep depression because I would like to be able to brew stouts, and I fail at it horribly. But it's usually IPAs. I'm pretty skilled at these. Yeah, you're welcome.
Hello. Hello, I'm here. Yeah.
Yeah. Oh, there. Yeah.
When you were describing the situation when we just cannot predict something that's going to happen,
yes.
We cannot think of all the possibilities. Don't you think that we are just poor programmers yet? And at some point, we'll invent a system that can predict, and then we'll automate everything.
I think there's a fundamental problem there. You can't come up with an exhaustive, complete list of things that can go wrong. That is the inherent problem, because it's an endless list. But if any of these instances materializes, humans are really good at detecting these. Machines are not, because you need to put an algorithm in place that detects exactly that specific instance. But I'm sure that the more it advances, there will be machine learning algorithms that will be able to classify something into that. I don't see that yet. And another thing, there are these testers that are very dismissive of developers in the sense of, okay, oh, they didn't do their job. No. It's mostly rooted in not understanding how difficult developing software is. So I have a deep problem with testers who dismiss developers as being incapable. Absolutely.
Смотрите, у нас в зале 3 микрофона, 2 переносных, 1 в центре. Кому как удобнее, тот так может и...
Something like that, yes.
Hi. You talked about skills of the tester, and my question is, what is your personal opinion? Should a real skillful QA engineer know algorithms and data structures and sort of things?
My answer to that is yes. If there is no understanding of algorithms, then that's the same thing as someone who works in a bakery who doesn't know what flour is.
Thank you.
Все. Во.
Over there.
Hello.
Hi.
Can you please provide an example what testers do not do?
What testers?
Do not do. You told about not to-do list.
Aha.
Can you please provide an example?
Well, not to do, for me, belongs in things like not getting certified. That is one thing not to do. Then the other thing not to do is being dismissive of developers. One thing not to do is to claim to have truth. So again, so this list that I come up here, that's not the truth, that's my opinion. That's something else. What I see in the community a lot is people who claim to be in possession of the truth. That is very dangerous. If you're in the truth business, then that's where ISIS and these kind of things happen. That's very dangerous. So when I say be skeptical about things, that also means being skeptical about your own opinion about things and never claim that these are true. So you should maintain a healthy level of uncertainty within yourself. So these are a couple of examples. Yeah.
Why did you choose testing specialization in your life?
Well, I was young and I needed the money. No. No, it was when I was when I was 30 years old. I went back to university and I studied sociology and linguistics, and then I needed money. That was the reason. And then I looked for a job and there was a job for testing, and I thought, well, I probably can. I know computers, I can do that. And then I started to like it, and I stuck there. So it's not, it was 14 years ago, so it's a long time ago, but I just started to like it and got stuck there. And will probably remain in that field for, well, until I'm older. Okay, so just maybe a last comment here. So if you want to have a couple of links or so, just hand me your business card, or you can have mine, and I can send you a list of things that I like. That doesn't mean that's the best list of testing methods in the world, but it's the one that I like. And if you want to have that, I'm happy to send it to you via email. Okay, thanks a lot, and have a good conference.